Welcome to our channel. Today, we're diving into the world of science with some exciting experiments you can do right at home. With a few simple materials, many of which you probably already have in your kitchen or garage, you can unlock amazing discoveries and have a blast while you're at it. So, put on your thinking caps, gather your materials, and get ready for some science fun. Let's get started. Alright, science explorers, let's kick things off with a classic, the baking soda and vinegar volcano. Now, this isn't really how a volcano erupts, but it's a fantastic way to see a chemical reaction in action. You see, baking soda is a base, while vinegar is an acid. When they mix, they react, and that reaction creates a gas called carbon dioxide. It creates pressure inside our volcano, and voila! An eruption of foamy fun. It's a simple demonstration of how different substances can interact in fascinating ways. But here's a thought. What happens if we change the amount of baking soda or vinegar? What about the temperature? Experiment and see what happens. That's what science is all about, asking questions and testing out your ideas. Now, who's ready to make a volcano erupt? Get your mixing bowls ready, because we're about to dive into the gooey world of polymers by making slime. Now, slime is more than just a fun toy. It's a fantastic example of how polymers work. Experimenter 2. When we mix glue with a solution of borax and water, something amazing happens. The borax acts like tiny little bridges, connecting the long chains of molecules in the glue. These connections create a network of tangled polymers, and that's what gives slime its unique properties. You can experiment with different types of glue, add food coloring for a vibrant twist, or even mix in some glitter for extra sparkle. Remember, slime can be a bit messy, but that's half the fun. Just be sure to clean up afterward and always wash your hands after playing with slime. Ever wanted to send secret messages like a real spy? Well, get ready to unlock the power of invisibility with this experiment using lemon juice. It sounds like magic, but it's pure science at work. Lemon juice contains carbon compounds that are colorless at room temperature. When you write with lemon juice on paper, the juice is absorbed into the fibers of the paper. Experimenter 3. Now, here's where the science gets really cool. When you apply heat, like from a light bulb or an iron, those carbon compounds in the lemon juice oxidize, creating a brown color, making your invisible message magically appear. So grab a lemon, a cotton swab, and some paper, and get ready to unleash your inner secret agent. Remember, safety first. Always have an adult help you when using heat sources like a light bulb or an iron. Get ready to make a splash with this colorful experiment that explores the concept of density.
We're going to create a density rainbow, a mesmerizing tower of liquids stacked according to their densities.
Density is a measure of how much mass is packed into a given volume.
In this experiment, we'll use common household liquids like honey, corn syrup, dish soap, water, vegetable oil, and rubbing alcohol. Each of these liquids has a different density, which means they'll form distinct layers when carefully poured into a tall glass or cylinder.
Start by pouring the densest liquid honey into the glass first. Then, carefully layer the other liquids on top, starting with corn syrup, then dish soap, water, vegetable oil, and finally, rubbing alcohol. Make sure to pour slowly and carefully to avoid mixing the layers.
As you layer the liquids, you'll notice that they don't mix. Instead, they form a beautiful rainbow of colors, with the densest liquids at the bottom and the least dense liquids at the top.
Remember lava lamps, those groovy relics of the past?
Well, today, we're going to recreate that mesmerizing, bubbling effect right in our own homes. And the best part? We'll be exploring the science of immiscible liquids along the way.
Immiscible liquids are liquids that don't mix, like oil and water.
In this experiment, we'll use oil and water as our immiscible liquids, and we'll add a few extra ingredients to create the bubbling lava effect. First, Fill a clear bottle or jar with vegetable oil, leaving some space at the top. Next, add water to the bottle, leaving about an inch of space at the top. You'll notice that the water sinks to the bottom, while the oil floats on top.
Now, add a few drops of food coloring. Finally, break an antacid tablet into a few pieces and drop them into the bottle.
Watch in amazement as the antacid tablets react with the water, creating bubbles of carbon dioxide gas that rise through the oil, carrying blobs of colored water along with them.
Can you fit an egg into a bottle without breaking it?
With a little bit of science and air pressure, we can make it happen. You'll need a hard-boiled egg, a glass bottle, a piece of paper, and a lighter. Light the paper and drop it into the bottle. Quickly place the egg over the mouth of the bottle.
The flame heats the air, which expands. When it goes out, the air cools and contracts, creating lower pressure inside.
The higher outside pressure pushes the egg into the bottle. Always have an adult help you when working with fire.
Ever wonder why your hair stands on end when you rub a balloon on your head?
Well, get ready to explore the electrifying world of static electricity with this simple experiment.
Static electricity is all about the movement of electrons, those tiny particles that carry a negative charge.
When you rub a balloon on your hair, you're transferring electrons from your hair to the balloon.
This creates an imbalance of charge, with the balloon becoming negatively charged and your hair becoming positively charged.
So, the negatively charged balloon will attract the positively charged strands of your hair, causing them to stand on end as they try to get closer to the balloon.
You can also try sticking the balloon to a wall after rubbing it on your hair.
The negatively charged balloon will attract the positive charges in the wall, creating a static cling that keeps the balloon in place.
It's a fun and easy way to see the invisible forces of static electricity at work.
Get ready for a sweet treat that's also a fascinating science experiment. We're making rock candy and exploring crystallization.
Crystallization forms solids with ordered structures like snowflakes.
We'll use supersaturation to create our rock candy. Dissolve sugar in water until it can't hold anymore. Heat the solution to dissolve more sugar.
As it cools, sugar molecules slow down and bump into each other.
They attach to a string, forming a crystal lattice.
Over time, more sugar molecules join, creating larger crystals.
After a few days, you'll have beautiful rock candy crystals.
Get ready to witness the magic of capillary action with this colorful experiment. We're going to make water walk uphill, defying gravity with the power of science.
Capillary action is the ability of a liquid to flow in narrow spaces, even against gravity.
In this experiment, we'll use colored water and paper towels to demonstrate capillary action. Fill several glasses or jars with water and add a few drops of different food coloring to each glass. Next, cut strips of paper towels and place one end of each strip in a different glass of colored water.
As time passes, you'll notice that the colored water starts to travel up the paper towels, defying gravity.
The water molecules are attracted to the fibers of the paper towels, and this attraction, along with the cohesive forces between the water molecules, allows the water to climb upwards.
Eventually, the colored water will reach the other side of the paper towel bridge, mixing with the water in the adjacent glasses and creating new colors.
It's a mesmerizing display of capillary action and a colorful reminder of the hidden forces at work in our world.
Get ready for a colorful spectacle that seems like magic but is pure science. We're going to create a swirling, dancing display of color using just milk, food coloring, and dish soap.
This experiment explores the interaction between fat molecules in milk and the properties of soap.
When you add dish soap to the milk, the soap molecules break down the surface tension of the milk and try to surround the fat molecules, like tiny little bouncers trying to break up a party.
The food coloring we add to the milk gets caught up in the action as the soap molecules chase after the fat molecules.
The food coloring swirls and dances around the milk, creating a mesmerizing display of color and motion.
It's like a miniature fireworks show in a dish.
Experiment with different types of milk, like whole milk or skim milk, to see how the fat content affects the results.
Thanks for watching. We hope you enjoyed these fun and educational experiments. Keep your curiosity alive, ask questions, and never stop experimenting. Don't forget to like, subscribe, and hit the bell icon for more exciting science videos. Until next time, Keep those brains buzzing and remember, science rules.